in case folks are still experiencing issues with connecting to AWS from a Windows machine, then Taib has a link which kind of closely mirrors what we also saw in the class. But in Windows users, if you haven't kind of settled down on the issues from last time, you can look at this Medium article. Okay, so it's on the chat. So second thing is actually a big topic, which is related to project, which is something that you want to start working on soon. So let me share my screen with the project page. So some of you have already reached out to me asking for some more guidance or some more structure, some information clarification questions about what the scope is and what you can choose and so on. So as you know, there are lots of choices for what could be something that could constitute a project for this course. As I was mentioning it to one of the students earlier, let's see, basically informally, and certainly have a look at this page when you get a chance, maybe during the break or sometime soon. Basically, informally, what the scope is quite broad. It's any technology which is adjacent to the model building aspect itself. So whatever you've done in 572, 575, or any of these machine learning stats courses, most of them typically look at batch data and focus on model quality, model diagnostics, train the model itself, test train loops, and so on, right? Whereas here the objective is to come up, look at some interesting technologies that have come up. Some, for example, like some names are given in this report itself. For example, MLflow versus Bento ML versus Cortex, but it doesn't have to be these particular names. You can Google them online. For example, somebody last time was suggested SageMaker. SageMaker is an offering by AWS. You can look it up. When you go to AWS's services list, you will see SageMaker as one of the options. Or you can look at like how do you work with machine learning when you also want to use Git, for example. Like you can use GitHub Actions for some things. So there are many technologies that we have not seen in the class that you might have come across elsewhere that you want to, as long as it's adjacent to the building, the model building process itself, is something that you can try out. Okay. In the class, as you saw, we are looking at a very narrow and very specific technologies, which are listed here. So, for example, we looked at Flask-based deployment of trained ML models. We looked at similar trained ML models, but the simplest ones. In fact, we only tried regression here. You can also do scikit-learn-based ones, and that could be an interesting project by itself. If you want to use a serverless, you want to demonstrate how to use serverless technologies for one-off, like like something like a scikit-learn model, how to deploy it using either AWS Lambda or Cloud Function. You could show how to use Docker to containerize or build an image with your model and all the dependencies, and show how you are able to export it to, let's say, either the Docker file itself or read it from a public registry like Docker Hub, or a private registry like the cloud, Elastic Cloud, the Google Container Registry, or one of these private registries. We have not seen it yet. You can demonstrate if how that flow would work, and you don't have to do these. Okay, so there are many examples in the exercise questions in each module. Also, some other technology that you might have come across, you can always pick it up. Okay, or you can also do similar to what we do in the class, but certainly have your own spin to it because you don't want to do exactly the instructions in the class. So they're all on the idea side, but in general, the scope is quite broad. Pick anything which is compatible with your level of skill. So don't pick something which has a high amount of complexity involved, like Kubernetes, for example, has a relatively higher complexity than, for example, just working with Docker and let's say Docker Compose or something like that, right? So there are some technologies which are harder, but some are easier. And if in doubt, we will please reach out. In fact, my suggestion is, so there are 3 weeks to the deadline, right? So if I look at the, so we are here. So there are 2 more lectures, and then there's a deadline for your own presentation. So the next 2 weeks, I'm suggesting, and there's going to be in-person classes. So I'm suggesting after the class, which is during the office hours, you can stay back and discuss the projects with me, right? So I highly encourage you to try it out to see if you can discuss with me, either the week of 14th, on 14th or 21st. Okay, there were a couple of more related questions about this, and let me then ask you guys if you need more clarification. But what you want to document is kind of suggested in this instruction page, and this is not one size fit all type of a suggestion. It was just a suggestion for some projects. It makes sense that you want to talk to other business analysts. Okay, so your report basically is supposed to summarize, hey, this is an interesting technology. Let's say Docker is an interesting technology. Where does it fit in a typical workflow? Why use it? Why not use it? Here's how we have used it to deploy an example model, whichever model, pick it up from based on your domain expertise or previous classes and so on. And so that's one example. Of course, Docker is something that we're covering in the lecture, so you may want to do something different or something more interesting to you, perhaps. So this kind of gives you some sense of like, how do you want to write it? At the same time, it is a short report, so don't worry too much about covering everything about the underlying technologies. It's from a user experience perspective. Did you face troubles using the approach, using this technology, or not? Okay, and what was, if you have some recommendations for other users, that would be even great, right? So those are my, I guess, impressions that I wanted to kind of mention about the project. But the summary is that it's due in 3 weeks. In fact, 3 weeks from now, you will present at least your attempt at trying out a technology in the class. So if you haven't started, you do want to get down to a scope which is feasible based on your skill set and your team member skill set, and start working on it, and then talk to the TA and myself, if in doubt. I don't think I have other points, but they're all very specific. So is there anything that comes to mind to any of you? Any questions about the project scope and grading rubric and so on, which are listed here, but you can use mic or you can use chat anytime to add your comments or questions. Okay, so if there are no questions about the project component, then we can perhaps resume where we had left last time. So before that, actually, let me also ask. So last time we covered serverless functions, and then we're trying to get started on Docker as a technology, and we installed it, and I think we just stopped around trying out Hello World, and then I created a simple, I basically ran one of the Docker files in the example directory, and I built an image, and I started a container based on it, and just showed you, it was a weather example. So I just ran it to show you that, hey, it's when you make a request, it's going to the machine and then going into a container inside the machine, and then you're actually getting, and some script is running inside the container, and then you're getting that detail. So any questions about up to that point, or any hurdles that you hit? I hope by last time you have crossed the hurdle of setting up let's say an AWS machine or anything else, and be able to run Jupyter like how I have. So this is really from last time. anybody has a comment, question that they want to repeat, because I don't want to kind of jump ahead and talk about more complex technologies. If we want to spend a little bit more time on let's say serverless or Docker, will spend some more time today to wrap up some things. Then let me know.
Professor, is there a way to transfer your data from your computer to the AWS machine? Like how to do that?
Yes, that's a great question. Yes, we can. Let me. So actually, yeah, yes, we can. I mean, since I don't want to, okay, I can show it to you here. So I'm already in the AWS machine. Okay, so this actually. So I'm already in the AWS machine. Let me try if I can try. Okay. Actually, so I'll show it to you by just logging into the same machine. So by showing you one way to do it via command line. That's not the only way. You can use some programs also, whether it's on Windows or Mac or elsewhere to do it. So let me. So so what I'm doing is just setting up so that I can show you that example. Okay, I just copied a public key to this machine, which I generated from the same machine. So it should hopefully let me log in. So what I did is I SSH from this, from this remote machine to itself. Okay, but it doesn't have to be itself. It can be some other machine. Okay. We know that from last time and this time's setup tie-up that we can actually SSH into a remote machine, right? So we were able to do it from our local Mac or Windows to the AWS machine, right? So in addition to SSH, there is a sibling command called, let me just exit from there. So you can actually call SCP. Okay, so let me check if there's a file. So okay, so what I'm going to do is go to, let's say, MLOps examples. I'm going to create a file called, my name, let's say. There's some file which is in my folder. Now I want to send it to this remote machine, right? So like the AWS machine. The way you do it is called SCP. Okay, so SCP minus, it's exactly the same command as before, SCP minus, if you want to use, so you don't have to use identities and all that. Actually, you can, sorry, minus O and all that. You can actually directly use minus I, AWS. Okay, it's not here. So actually, I'm not using the PEM file here, but let's see, SCP, that's a Teja. .text. So SCP just means secure copy. Okay, it's basically copy on via the SSH protocol. So SCP file name, and then typically whatever your username is, like Ubuntu @ 3. I mean, for me it's 3. Some IP address, but okay. And then don't forget the colon. Colon just means like what and where do you want to put this file. Colon just means like the user's home directory. So if I press this enter, so actually first time if you try, it'll say, hey, is this the right thing? Say yes. And then it says, this file was copied into this machine. Okay. It turns out, it's the same machine, so I can just show you what happened. That file came here, right? So it's here. right? So the file just got copied. Now, I mean, this is showing in GMT or whatever UTC time, so -6 hours, I guess. So I just copied this. Okay. So any file. So as long as you have, here I used SSH file name and then remote location colon just means the default directory. You can do instead of colon, you can say tilde / like MLOps code examples or something like that. You can do this. Okay, so but for at least the beginning point, if you have a zip file, you can do the same. Here you can say something dot zip, and you can copy it this way. Okay, so the only change you need to do is that I did this like this, but if it's not working, then you should add that key file. So I don't know, AWS, I forget the name. AWS machine. I mean, I use AWS machine 22 in the class, but if you wanna, so that's just saying which key file to use, but then file name and the remote location where you want to put it. Okay, does it make sense?
Yes, thank you, Professor.
If not, so this, there's nothing more except that there's instead of SSH, it's an SCP. And of course, you need to give source file and then the destination location where you want to put it. Okay. Now you must say, hey, how do I get something from the remote machine, AWS machine, to my local thing? You can just do the opposite. Okay. So for example, you just flip the so in the remote machine, what is the file you want to pick? Should be after the colon, the file name. And then the current directory is just dot. Okay, so current directory is represented by dot. So I can just show it here, / something like this. Okay, you remove this extra. So this is the remote file. Oops, sorry. This is the remote file location, and dot just means current directory, whichever, let's say downloads directory that you are in. Okay. If you want to copy something from the remote machine to you. If you want to copy something from you to the remote machine, that's the file name, and then a colon to get to the regular, the home directory, and from there you can just move it. Yeah. Okay. Anybody else has any question? Okay, looks like no questions. So, okay, since it's going to be interactive and we are everybody is in front of their machine, so let's actually try to get Docker set up. And if anybody has any trouble, I want to kind of iron that out now before going to next steps with Docker. Because if we are able to run one example, we should be able to run more. So we want to get to the stage where we are at least start out setting up Docker, which we did last time, and be able to run the Flask weather service that we ran, which basically there's a file in there. You just have to run a specific command in there. So anybody has a question about that? So if you did that last time and you just want to get, if you just want to remember what you did, sudo docker images will tell you what images you created last time. So last time we created the weather image. It started with a Debian image. Okay, so images are just, so just think of images as like some sort of files, and the remaining comments, remaining statements, and the green indicates that those are the statements, those are the steps being followed to create a new image. So you start with some image, what is called a base image, and then you add your stuff, which is we installed Python specific details, so Python as well as Flask, GeoPy, and requests. And then we said, okay, now I've installed everything. I installed everything which is needed and while I'm creating this image. Let me also add my file that is needed. And once I add this, I also need to specify, once I create a container from this image, what needs to be run. And all the specification is in the Docker file using which we built that image. Okay, so that image is, okay, sorry, not here, but that image is here. Okay, so since it needed Debian, so Debian was downloaded, and then we created this image. Any questions or concerns about this? at least the operations. So what I wanted to do is get back to the slide deck, just to recap like the larger picture of where we're going, and then also discuss the goals for today before we get into some specific details. But if you have questions about setting up Docker, there's a good time. Don't be hesitant. It's okay to miss some more advanced topics so that we can at least be more comfortable with the things that we're seeing. Just want to give a very high level view. We are almost in the middle of this 2-credit course. So we kind of are wrapping up batch machine learning models and inference. Okay. In fact, I might skip Kubernetes today in favor of some of the other topics, given that we have 2 other, like a total of 3 sessions remaining. So just to give a larger zoomed out view, we have kind of addressed the first bullet point, which is, hey, if you already have a trained model, how do we expose it to users, basically? How do you expose it as a service so that people can make requests? We just picked up HTTP as the protocol. So we would make GET or POST requests. And then, because the model is hosted, it's running live on a server, either on an AWS machine or AWS Lambda or Google Cloud Function or anywhere else. So it can respond, it can wait, get that request, look at the feature vector, passes the model, call model.predict or something like that, and then return the response as either as a JSON object or a plain text or whatever it is, class prediction or whatever it is. So we saw 3 different kind of approaches: web servers, serverless services, AWS Lambda and GCP. And we just got started in Docker. In Docker, we didn't deploy a Flask model, but we can actually do that today. Just to show that the weather example is not too canned, we can always create something else, and we'll actually just do it with simple regression, just as a practice. So if you are trying to start with Docker today, we'll just do a quick recap of Docker with the simple regression examples that we've been using throughout. Okay, just so that it's kind of easy. And then so the second part of using Docker or in general container technology is that it's very aligned with a lot of other non-machine learning processes that happen in tech companies or in general companies, especially companies which have digital products or digital products and services and so on. And so they all use containers. Okay, so containers are a way to create infrastructure where you don't worry too much about the actual machines and actual containers, but you care about creating nice images and programmatically dealing with replication of images, replication of services. For example, you may want to have 10 different machine learning prediction models running simultaneously, because maybe each model is taking a second to compute a prediction. Okay, so you can create 10 different you can run 10 different containers simultaneously and things like that. So those are achieved using a service called Kubernetes, and I'll briefly show you the slide deck as well. And Docker is one technology, but the behind the scenes, as I said, the core object is an image, and images can be shared with each other, between team members or between organizations or with public, using a public not repository, but a public registry. That's called, for example, we saw Docker Hub, from which we got Hello World example, right? So this as well as this, actually Debian, both were downloaded from the public registry that is hosted by Docker Hub. Okay, but if we create our image, which is the weather image, we can so we can submit it. If you want to keep it private, it's a company image, and it's a company IP. So if your firm is on AWS, you can submit that image to Elastic Container Registry so that it's available to other teams and maybe for yourself as well inside your own infrastructure. Okay, and similarly on Google Cloud, it's called Google Container Registry. So the process of sending an image to the container to these container registries is not too complicated, but it does take time. So I don't want to spend time on that, and so we may skip using these managed services. Okay, but the managed services are, and we'll talk about this in a little bit, for a few more minutes when I talk about Kubernetes, at least to give a sense of what it is. So that's another. So images registry. And so those are the two things, like you create an image locally or elsewhere, you put it in a registry and other people can use it. Okay, other people can create containers from it. So just like this weather image that I created, I could have shared it on Docker Hub if I have an account there, and then you guys could download it and run the same thing. It doesn't have to be weather, it could be any models. For example, Tayyab could have a model maybe related to stock forecasting, Chris could have a model related to weather forecasting, or two different domains, and they can share these containers, so these images, so that the other person doesn't need to know everything behind the scenes that's going on for such an app or such a script to work. Okay, we come back to the slide. Coming back to the high level view, the next three topics, and we'll actually pick up testing today, and then also these other two topics. So the next topic is model retraining, versioning, and testing. Okay, so we'll actually spend a little bit of time on two of the technologies here. So this topic is about how to schedule repetitive tasks. Okay, so in machine learning in production, generally you may have to update your model every week or maybe every month or maybe every day. So you have to fetch new data, run the training loop and generate a new model and so on. So that step can be achieved if you are on a single machine using some very traditional services like cron. Cron is a utility that's available in many Linux systems, which lets you schedule in general any process, like, hey, this process should run at 10 in the morning, this process should run at 5 in the evening. So you can do that. And there's also a more elaborate tool called Airflow, which lets you also schedule jobs. And the last part of this bucket is testing. So if you have a model, you're able to periodically retrain it and you're able to deploy it using the first set of technologies. How do you test its effectiveness? Because offline testing of models, is fine. You can always create a test data set and look at what is the test performance. But generally, especially in some domains, for example, recommendation systems, it's not easy to have offline metrics which reflect online metrics, right? So in offline, you may look at things like precision and recall, or other scores, but they don't exactly capture how the recommendation system is performing when it's actually exposed to users. Okay, so there could be gaps, and so you may want to test your model. So this is not related to unit testing or integration testing. This is it's called A/B testing. Okay, so we'll briefly discuss that today. So today's scope is this, and then in the next lecture, so depending on how much we cover, in the next lecture we'll look at distributed data processing, where whether you can want to train model or whether you want to just process the data. How do you do it in beyond a single machine? And so that's that one example technology there is called Spark. And the next lecture after that, we'll look at how to deal with multiple different services. Okay, so there's some maybe software written in some other language like Java, which is processing the data. There's some other service, or like our web app, which is written in Python. How can they interact, and how can they interact in a singular I guess system, and be able to work with each other? Okay, so there are some ideas there about what is called streaming setup, where you think of some services or some apps or programs producing data, or what I call messages, or publishing messages. And there are some apps, services, programs, scripts, which are consuming messages or consuming data or consuming requests. Okay, so there is some producer consumer architecture that's popular, and it's called streaming infrastructure, and we'll talk about that. Okay, so that's was I want to give you a sense of like where we're going today and the next couple of lectures. So we'll skip over container orchestration and focus on scheduling jobs, and hopefully scheduling machine learning jobs, machine learning A/B testing. Okay, A/B testing is it's a statistical procedure, and we look at that and try to set up actually using an example package in Python. And the next couple of lectures, we'll look at hopefully distributed data processing, as well as streaming data processing, or streaming machine learning. Okay. Actually, I don't have chat window in front of me. Let's see. Okay. Is the syllabus or at least the idea clear of where we are and where we're going? Yeah, if something is not, yeah, thank you. So if something is not clear, let's actually like spend some time on it. Just like, Tayeb asked a question about how to copy data from here to server. So please ask. Yeah. Somebody had a comment? Okay. So I'll go ahead. So what we've done is last time, although yeah, so Harshit, you're asking, can you create a Docker image? Yeah, we're going to go through Docker and then talk about today's topic. But I wanted to, like use the slides to talk about use the slide to talk about Kubernetes and then come back to Docker. Okay. So today's goal, we'll kind of talk about today's goal, which is about scheduling models or model related jobs, as well as A/B testing in a second, but we'll talk about Docker now. Okay, and so we'll cover how to create a Docker image soon. So let's talk about Docker actually. As I said, the high level idea is the following, right? So you have local development. Local development, just think of the Flask script. Okay, so we have a trained model, some pickle file or some PyTorch file of weights, or even just the weights of a linear model. Okay, maybe logistic regression model, just the weights in a a list, like maybe CSV file. Okay, so we have a script which can read those numbers and use that as part of your model. Okay, linear model, let's say. So how do you kind of package that script? Okay, so of course there's different notions of packaging. You can always make a Python wheel or Python module, and then the module can be downloaded from some repository or something like that. Here, what we're concerned with is that if, let's say, we want to deploy the ML model. Okay, deploy the ML model means make the model, put the model inside a web service and let the service run maybe on Lambda, maybe on other machines and so on. So that's in that context, what we do is use our script and the model, model parameters, and create an image. Okay, so this image is a specific vocabulary in this, container, containers domain. So image just means it's basically a precursor to running a container. So if you kind of run a container from an image. Okay, so we'll see how to go from a file to an image, like our Flask script to an image, and from image how to run a container. We'll kind of recap that. We can once we have an image, we can do 100 different things, and that's what this figure is trying to show. That if you have an image, you can always run that, run a container from that image locally. Okay, once you have an image, you can ignore everything else. Like we don't know, we don't care what's inside the image, as in how it's implemented. We know that this image maybe makes a prediction at some port. You just need to make a request and it's going to produce a recommendation or a prediction. Then that's all you need to know. Okay, and so you can run a container from the image locally, or you can actually send that image to other locations. So that's what I was mentioning in the very initial slide, that sending that image requires using a notion of uses the notion of a registry. Okay, registry is just a placeholder where you can send this image object. Okay, it's very similar to, hey, if I have a zip file, I want to put it somewhere else, you just secure copy it, right? So is one example way to do it. And there are also graphical ways, GUI based tools to do the same copy. Similarly, images are put in repositories, put in registries, and then from registry you can run the same container. Okay, so this ML model prediction service container in any place, whether it's a cloud or your own server, maybe in some other third-party vendor, maybe your own data center, maybe in your own office, but some server room and so on. Okay, so that appropriate other people can consume it, right? So that's the idea, this portability, while other people, in particular, wherever you're sending this image to, they don't have to care about any dependency except for them having a way to run the, except for them having a way to create a container from your image. Okay, like typically a Docker runtime available there. Okay. So we didn't see, so we're going to get to hands-on recap of the Docker, running the Docker container in a second. But last time we saw briefly the setup, right? So Docker, when you install Docker, basically you're getting at least two things. Okay, there's the Docker client, which is the command. Like if you see, we'll do sudo Docker, or without the sudo also, Docker space something. So that's a command line program. Okay, that's like very similar to ls, cd, and so on. So that program is actually talking to a service. So there's actually a Docker daemon service. Daemon service just means it's a background service that's running when the computer started, for example. Okay, it's a service, or it's a program that's running behind the scenes. And Docker command line client, every time we say, hey, sudo Docker images, right? For example, here I said sudo Docker images. This client spoke to the server, and server said, hey, here are the images that I have. Okay, so that's how it's set up. So that's the Docker runtime. There are other runtimes as well instead of Docker. If you don't want Docker, there's alternative implementations by other vendors. Podman is one example name. There are other tools which are not specific to Docker itself, but they are one layer above, in the sense that, hey, if you had hundreds of images and if you had to run thousands of containers, okay, which is, by the way, it's not, it is the case for many large tech companies to run hundreds of images and thousands of containers, okay? And so for them, they use a tool called Kubernetes. So actually, so that's where these extra things are useful. Okay? In Kubernetes, minikube is just something that you can try out on your own laptop to get a feel for how Kubernetes works. It'll create so Kubernetes is a cluster-based solution to orchestrate, as in manage multiple images, multiple containers. They're all connected to each other, doing different computations, but achieving some very complex, outcome, like as a software, right? As a cloud software, for example. Okay. In that context, there's also a different language. We're not going to look at that, but it's some type of a YAML is just a text file, very similar to this text file that we saw here. So it's similar to that. I don't want to explain too much. I don't want to get into details of it, but it's just a text file of us. Let's just specify, for example, how containers should be run, what port should be open, and so on. Instead of us writing explicitly, right? So here, for example, instead of us saying, so you can see that this Flask app has been running actually since the past 6 days, since last week. But the way we run it, we're going to see it in a second. Instead of running it via a command like this, we can create a file and then run that file. Okay? So that's what a YAML-based way of specifying how to run your containers or images is. We'll not get that's not its only use. It has been used in other places, but that's the use in this context. Okay. So in particular, let's come back to Docker. So you're going to use sudo docker star. Star just means, we'll see some commands today as a recap. This is what we've been using. But if we were gonna try out the Kubernetes module, the notes are there, but we'll kind of skip that for today. You will try, these other commands, okay? And we'll also skip these cloud services for now. But as I mentioned, once we create an image, we can share it on either Elastic Container Registry or Google Container Registry. These are not the only registries. There are other places to also, put it so that it's slightly different from putting it as a, as a file in a folder. Okay, it's slightly different than, but the same mechanism, same analogy holds. So you kind of put it in a shareable space so that other people can pick up that image and run it. Okay, that's the idea. So that's Docker. Let me see if I have. Okay, so let's actually finish the Docker part, as in redo once more how to create an image and how to run a container from an image. Okay, and then in particular, we'll do it slightly differently than the example that we have, and then we'll get to the scheduling and testing topics for today. Okay, So let's actually come back to the tab. So you can see, see. I think it's a couple of examples. I'm trying to figure out. Okay, let me actually stick with this. So let me walk through an existing example first, and then we'll slightly change it. So what I'm going to do is first delete the things that I created last time so that we can start from a fresh starting point. Okay. So sudo docker. So you saw that there is actually a container that's actually running right now. This is actually exposed to port 5000. Okay, and we'll come back to how this got exposed to 5000 soon when we spin up the container again. So this is actually exposed to, since it's exposed to port 5000, instead of like showing you the real, the full world, we can actually just test it right here. So you can just do curl localhost 5000 question mark. If you remember, this was actually supposed to be weather. So message, let's say Chicago, right? So if I just do this, I get a huge, I think this is what probably we did last time as well. So this is a JSON object. It's just saying, hey, Chicago is somewhere, and what is the weather, what's the wind speed and all that. So what we did here was actually make a curl, make a get request. Remember, it's a get request. We made a get request to a process running at port 5000 of our machine. So our machine is this server machine, our AWS machine. At port 5000, that 5000 are actually connected to the containers port 5000. Okay, so it's like, hey, I'm just asking, hey, at my machine, localhost just means my machine. Okay, at port 5000, ask the weather. Okay, but my machine's port 5000, or I could change it to some other number, is just connected to the container within which the Flask app is running at port 5000. Okay, so that connection we'll see in a second how we made it when we started the container. And so within the container, this class has, gets this message Chicago, and then it itself goes outside of the internet and queries some other service and gets the information and then passes it back to us. Okay, so that's what it was doing. So I think it's called stop, I believe. If not, let's see. Okay, so now that particular container has been stopped. So the container, by the way, was running again as a background service. Okay, so it means that it will run till you kill it, or till you kind of control C, or basically somehow kill the process. Okay, so but it's not removed. So if you actually want to see, if I do ps -a just means all, you will see that weather container, that exact container that was running, is actually still there. It just says exited 30 seconds ago. Okay, so it's still there. It is just you can delete it. Okay, so you can do, if you want to really delete the container, although it doesn't show that it's running, it's a running container. If you want to delete it, you can just do rm, and then you can see that particular container is gone. The other ones are still there, but you can always delete all of them. Okay, so I just wanted to show you that. So actually, let's so there is no containers running. Now let's actually go back to our So these are the three images. Okay, images are just like static files. Okay, they're not doing anything active. It's just from the static files you kind of run a service, which is a container, right? So RMI is a I guess a command to remove an image. Okay, so we're gonna delete this weather image. Actually, it takes a lot of time to build one. So actually, what I want to do is, instead of deleting this image, I want to I'm going to create a regression image very similar to how we created this one. So, okay, so let me copy Docker file, which is needed there, and also copy from our Flask example, regression. Okay, so I just created a different folder called regression image, just so that it's a completely different service. So it's a different container that we're going to build. Okay, so it has two files. You just need the Flask file. Typically, we're just going to use the Flask file. So that's what we are going to containerize. Okay, we're going to kind of edit this Docker file. Let me close the previous one. Okay, so we'll start with something. Okay, so it doesn't have to be this Debian buster. So you can also say Ubuntu. So there are some default starting points that you can use. Typically, it's a Linux image. So Ubuntu latest, if you want to say, it's just going to download that image. Maintainer, you can always give your name. And so for this image, you will see that the simple regression doesn't need anything else. You can see that it just needs, it needs Flask, and request, I think, as installed. So it's actually from Flask. So you don't need anything else except for Flask. Okay, so, and then you have model parameters. And I can actually change the port also. Let's say 80. Okay, so I just change the port to something else. Okay.
Professor, wasn't your AWS machine running on port 22? And
yes, it's so the SSH thing is running on 22. Yes.
okay. We still can do it.
Yeah, this is all inside the AWS machine, by the way. I'm not doing anything outside the AWS machine.
Okay.
So was there any confusion? Like, this port that I chose. This is just so that I just don't want to use 5,000. I've been using, we were using the 5,000 before, right?
Okay.
I just wanted to show you, like, hey, you can always use any other port. So I just choose 80, or, if you want to do 8080 or something, doesn't matter. So some port. I just want to check that this has one dependency, Flask. And so in the Docker file, we can install other things, but we can just drop these GeoPy. And request, I think, is being imported from Flask itself, so we don't need it. So this is what we need. So this is just you don't have to memorize this or anything. It's just installing Python and installing Flask. Now, why this way of installing Python? Why can't you just do miniconda? You can, okay. I think in one of the other examples, in the other Docker pipeline example, we do install Python via miniconda. Okay, so but I just wanted to not complicate things, so just do it this way. So Zoe is asking, can we include all the imports within the script rather than including them as part of Docker run? So within the script we are importing, right? So in the script we are importing Flask, right? Because the script needs Flask, when I create the image also needs to have that dependency. So I need to have that Flask so that when I run Python, whatever file name, it should be able to find that package, right? So I need to, so this installation, this apt-get and stuff is just what it's doing is, hey, start with an Ubuntu, kind of an Ubuntu operating system, and just install the minimum requirements. I mean, the requirements that are needed for the Python script to run inside the image. Okay, this is all. It's just trying to, it's like as if we are creating a new operating system where there's nothing else. We just want the minimum things that are installed for us to run our script. Okay? It's as if like we are starting a virtual machine or actually a physical machine where we say, hey, starting from Ubuntu clean install, just let's just install Python and Flask, and so that we can run our app, right? Like for example, if you had so let me just do it this way. So so you can also do copy dot space dot, which just means copy everything, whatever is there in the current directory, which is like a regression image. We are in regression image. The Docker file is in regression image folder. Whatever is in the current directory, which is these two files, copy all of them into the image. Okay, so this is copy into the image. This install things into the image, starting with some base image. And okay, and when the image is run, so in the sense that when a container is created from the image, start a particular file. Okay, so here we'll just say let's say my Flask app, and let's also change the name here. Yeah. So is this clear? What's happening? We just created. So this is just a way to say how to build an image. Okay, you could have a GUI which also does the same thing. There are probably GUI vendors which let you do this, but it's just a saying, hey, I have some app that I want to run containerized. Right? I have app. It need not be a single file, right? It could have like some, it could have a JSON file extra, or it could be dataset CSV files and so on. If you want to copy all of them, so that if all of them are hopefully in your repository or something like that, sorry, is in the image, then you can just do copy dot to dot. Dot just means first dot means current directory. Dot, the second dot means some default location in the image. So we have this Docker file, right? So Flask app name is correct, and everything else is fine. We have Flask, and Flask app also seems fine. We don't have to insert anything more. And hopefully if we hit /mlops, it runs from the container, and port is different. Okay, just for simplicity, just for some change. And now, okay, not this one, sorry. Now we just have to build an image, right? So sudo docker build minus tag. Okay, minus t means tag that image is something. Okay, so my Flask app, and then dot means get the Docker file from this directory. Okay, so which directory? So it has to build something, give it a name, right? A tag or a name, and where can I find the Docker file? From the current directory. I'm already in the regression image folder, so dot just means get it from there. So if I press enter, it's saying, okay, I see it. Let me start with step 1, which is get Ubuntu. Okay, I don't have Ubuntu. Sorry, I didn't have Ubuntu locally, so it went to Docker Hub and installed Ubuntu. Sorry about all this printout. So step 1, it said, okay, install Ubuntu. Step 2, maintainer is some name. That is easy to do. Okay, step 1, step 2 are, by the way, are just these. Step 1, step 2, right? Step 3, now it's saying, hey, run 100 different things. Basically install Python and install Flask. So just the step 3 is printing out a lot of information, but at the end of the day, it's just producing, it's just updating the Ubuntu image so that it is no issues, and installing eventually Python and installing Flask. Okay, so all this, all this is said, collecting Flask and install Flask and many other things that are required for Flask to run. Okay, now step 4 is copy everything that's there in the current directory, which is this directory, my Flask, as well as Docker file, but we don't need the Docker file, but copy everything into the image, okay, while making the image basically. And then the step 5 is just what is the specifying the entry point. Okay, so we have actually created the image. So so let's see, sudo docker images. You can see that my Flask app got created just 30 seconds ago. And we also got one extra image, which is the Ubuntu latest image. Okay, so that was the starting point. And so it was not there in the system. So we downloaded it from somewhere else. Okay, so that's how we build an image. It's the same process, but depending on what your exact requirements are, there may be slight changes needed. Okay, so for example, what to copy Maybe there are secret API keys or something that you want to, like PEM file, for example. You need a PEM file to maybe log into another machine. How do you copy them securely and things like that? So they're different, depending on the use case, there may be slight variations, but this is the, I guess, the core, this example is showing you like the basic of how to get an image built. Okay. So now we have an image. So let's run it. So the way to run it, if you want to run it manually, is sudo docker run, and you can just give the image name. Okay, so you can give image has name. So this is name, or basically it's called repository, but you can just use this name, or you can also pass image ID itself. Okay, so what happens is there could be multiple repositories or whatever can have the same image ID, but for our purposes, just think of this is the image name itself, my Flask app. Okay, so the problem is if I do this, then we want to run it as a service, right? So where we want to run the service such that its port 8080 is exposed to us, right? So when we run something, the script is running inside the container at port 8080, right? As we specified here. But how do we see it? We, as in the operating system, as well as the outside world. Inside the container, the script is running. Script will run when we create a container, right? Because it says entry point, so it says when you create a container from this image, you should immediately apply the command python flask.py, which means that the app is running inside the container, okay, at port 8080. But you wanna, even before starting the app, you want to say, hey, it'll immediately start something, but what I want, whatever it started at port 8080 to be exposed to me outside. I'm not inside the container, I'm outside. So I need to see it. Okay, so that's achieved by a port forwarding. So I can expose it to port, let's say 5001, because okay, there's nothing at 5000, but let's say 5001, and then to 8080 inside the app. Okay, so 8080 was the one inside the app. I want to just look at it at port 5001, let's say. So that's how I would do it. But even this is not complete. There's an extra option called -d. Okay, -d means it'll run as a daemon service. Daemon just means in the background. Okay, so if you don't add -d, let's run it and see what happens. You will basically not get a command. Okay, you will your prompt doesn't come back to you in the sense that you will not get this line. Okay, so because it's running as a foreground process. That's the difference between a foreground process. So it's running there. It's saying, okay, we run it. It's running at some port 8080, and it also tells you an IP address, but we can't use that IP address. So it's running at 8080. Okay, so now what we can do is just test it like before. So we can just do curl minus curl. I'm just using localhost. But if you're going to use it from outside, you can always use the IP address, the public IP address of your machine. Okay, as long as the port is open in AWS security group. I'm not going to do all that because it's 2 extra steps. So localhost, I guess 5001/mlops, right? So let's try this. Yeah, it says hello world inside the container, right? So that script, which is running inside the container, was able to reproduce this. And then I don't know what the other /predict. Okay, so if we do /predict, I mean, it should work. Right, input is 10 and prediction is 12, and so on, right? So this was a very simple example of running a container using a image. Okay, so what I did here was, and you can actually see what was also called. Okay, if it's in debug mode, by default, I believe it's in debug mode. Maybe debug should be off or something. Okay, so sorry, where did it go? Yeah, so you can see that the 2 queries that I made, you can actually see who made that query. I mean, it says some IP address, but generally you will see the right IP address and where did it go? It was a GET request and it succeeded. You were able to respond successfully. Okay, so those are 2 requests. Of course, it's not exposed to the real world, so you can't use it unless I expose the security group configuration AWS interface. But this is how you would do it. Okay. So the only difference is that I didn't add the -d option. -d option lets you run this whole thing, run the app in the in background. Okay. So right now I have no choice but to
Professor,
yeah.
I think in two classes before you told us about screens. If you, for example, if you run a different screen and just detach from it, that will serve the purpose here as well, right?
Yes, that does serve the purpose. Yes, but that's yeah, that does serve the purpose. So I just did a Control-C to exit, and so actually what happened is the container got killed. Okay, so if you look at sudo docker ps, you should not see the container. Okay, it got terminated. Okay, when I did Control-C, okay, it exited. That's because it was running as a foreground process. But if I run the same thing with a -d command, it'll run as a daemon. So it will not, it'll just keep running. So what it prints out is the container ID. Okay, so it'll produce a 64 character long container ID, and then but you'll see that the container is running. So it created 12 seconds ago, up for 11 seconds, but it's running behind the scenes. And so you can still query same thing. It'll still work. Okay. And so although we deleted a previous container, rerun the container. So from user's perspective, there's nothing changing. Okay. And you can run this container, once you have images at different places, you can run it from anywhere and it'll do the same experience, right? So as I said, we can run it via screen, but that's non-standard. Non-standard for at least this. So yeah. So does that help, Harshad? Or does anybody else have any?
Yes, thank you.
Yeah. Any questions about just this? Because I want to do the simplest version first, and then you can always add complexity, right? So what we did was kind of copy the Docker file from the other example and change what we wanted to change. So like it's it's a different app. It may have different requirements. Maybe it needs pandas as well. So you want to install pandas, right? So there are those types of things that you may have to change, like NumPy or something like that. So, but the nice thing is you can install all of that, and so the host system, wherever the container is running or container needs to be run, they don't need to install pandas. They don't need to install SciPy, NumPy, or anything like that. Okay, that's a good thing about it. And for example, you may also need to install, maybe you need Python, specific version of Python 3.10, for example. Most like on serverless technologies, you saw that there was only one or two options, like Python 3.9. But if you needed a specific version, because some software needs a specific version, then this is a good, good way to do this. Okay. Let me not include pandas.
Okay. So Professor, I had one more question.
Yeah.
So the way you are calling this, you passed an argument and you got a result back using curl. Let's say if you wanna continue that context, and you want to pass a second value which still works with the first value that you passed, can we do something like that?
Oh, you want some notion of a state?
Yeah.
So HTTP requests are stateless, unfortunately.
Okay.
So either the state can be maintained on the client side or the server side. Okay. So in the sense that if you want to, let's say you want to talk to the server twice. So in this case, it's a prediction model. You want to talk to it twice, right? So on the client side, of course, I can always remember what did I ask before.
Right. Yeah.
And that's what many apps do. Okay. So even the browser-based apps like Google Gmail or any of these things, right? So they remember some of the things on their side. Okay. So that the server doesn't have to remember as much. But the other thing is, because a server can also remember a state as long as it knows that it's the same client that's asking information. So for that, you need authentication.
Okay. Got it.
So because if server doesn't know, hey, request came, but is this request from person 1 versus person 2? As long as it remembers that, yeah, it can go back and it can always keep for example, a text file or a database entry saying, hey, this is what happened with this person the last time they spoke, or last time I interacted with them through a GET request or POST request. And so I can retrieve that information and then continue that state. That's the simplest. That's, in fact, I'm not, that's one of the ways to do it. Okay. That's if it's completely server-side state management. So that client
Got it.
just has to send some ID that, hey, I'm this person, now let's continue talking.
Got
So
it.
here we could actually, the simplest thing would be we could send an ID of, hey, who I am. And the
Okay.
server remembering like via a local text file or something, or local database entry, remembering what they did with you last time. Yeah.
Okay. Yeah, got it. Thank you.
Yeah. Okay. Any other questions about this? Okay. If not, actually, I want to switch topics. So what are we skipping? Okay, so I just want to mention that. So in the module related to Docker, last time what we covered was some background on, hey, what are the container technologies, how are containers different from virtual machines, and we created an image from Docker file. We also did that today with a slightly, these are simple examples, but once you get a simple example running, then you kind of add complexity to your script, to the Docker file itself, as well as deploying it at different places, right? What we did not do last time, as well as this time, is to push that image to a remote registry. Okay, so just like how I mean, we haven't done this as well, but for example, just like how we can send code, right? So like this is a bunch of Python files. How I push these files to a location like GitHub, right? So so that other people can download this code. Similarly, as I mentioned, images can also be shared in what is called a registry. Okay, hub.docker.com is an example of a public registry. They also let you have private images as well, just like GitHub lets you have public repositories or public code bases as well as private code bases. Same thing with registries. Okay, so we didn't see that, but that's another step, like what kind of useful for keeping snapshots of your images, or distributing your images, basically. Like you can do that via Docker, like a public image registry. There is, of course, usage limits. As you saw, these images are not small. As I think it is like this image, for example, is already like 500 MB, and this is 500 MB. So these are large files. Okay, so you want to be a little bit efficient in terms of, like, once you're really happy with the image that you have built, then maybe you should distribute it. Than like just to be a bit efficient. Another nice thing is I wanted to quickly show before I come back to that is, let's go to Docker file, and so in this Docker file, I did copy dot / dot. Instead of that, I can do my Flask app.py to app. Let me just use my app.py. Okay, so I changed the Docker file, right? But I changed step number 4. Okay, so if you think of like each green thing as a step, 1, 2, 3, 4, and 5. I kind of changed step 4. I mean, it's the same thing, but I just changed the text in the Docker file, right? So what you can do is, if you again go and let's say build this Flask app, it will detect that you only changed from step 4 onwards. So it will not take, it will not like, so you can see that I just rerun the building process, and it says, hey, step 1 was already done, step 2 was already done, step 3 was already done, in particular using cache. And then step 4 slightly changed. So let me start from there. Okay, so step 4 actually, although the invocation change is doing the same thing. So step 4, I only copied the explicit app file, and then step 5 is the entry point. Okay, so although if you have installations to be done, I think you should do it earlier, so that if your files keep changing and you rebuild your images, it won't take much time to rebuild the image. Okay, just wanted to point it out. I hope it's clear. Okay, so let me come back here. So the chapter that we will probably not get time to in this course, because we only have 3 lectures left, is Kubernetes. Okay, and we'll not look at details, but it's basically, as I said, it's about orchestrating multiple images. I mean, orchestrating just means management of multiple images, copies of them, if they fail, if the containers corresponding to the images fail, then how to restart the containers. So those all can be specified in a programmatic manner. And these containers can be run on multiple machines in a basically what is called a cluster, right? So a cluster, just think of it as a collection of machines. What this software does is kind of make you agnostic to is there 3 machines behind the scenes or 10 machines behind the scenes, doesn't matter. You just specify, hey, here's my ML deployment code or prediction service. I just want to run 10 copies of it. And if every time it fails, maybe because of some server edge case or something like that, just restart the containers. Okay, so always maintain a 10 containers always from my prediction service image. Then that's what Kubernetes can, that's one example of a use case where Kubernetes can help. And you can ignore whether it was, behind the scenes, it's these 10 containers are running on a single machine, 3 machines, or 10 machines. Okay, so that's the, and so if you want to experiment with it, the notes are there. If you want to experiment with a single machine, that's where you can use minikube to do it. Okay, but we'll skip that and talk about model pipelines and online experimentation. I want to start with the reverse order, which is do online experimentation first and then pick up pipelines. So pipelines involves that scheduling that I was showing. So we are actually at this step. Okay, this is what we're going to start now. What I want to do is do testing first and then do model scheduling, retraining, and so on. Okay. Any questions about what we're going to do next? Okay, so let me then mention what the goals are. So our goal is to know the different, just get exposed to this idea of A/B testing. Okay, we know A/B testing from our, let's say, IDS 570 or any of the previous previous classes might have covered A/B testing before. But here we're going to do it practically. So we will try out a simple package and some considerations of how to set up our Flask app along with an A/B testing extra logic so that we can do A/B test. Okay, so we'll talk about what is A/B testing and what are the different considerations. A/B testing basically has 2 parts. One is to actually run the experiment. So actually do the A/B testing where users come see one version of your website or the other version of your website, or basically user come and see one version of your model or the other version of your model. You collect the data, and then step 2 is actually to run a statistical test. And that's kind of probably some of you are familiar with, which is just some sort of a hypothesis test. So there are several hypothesis tests to look at, and so I'll briefly mention a couple. And hopefully the third part in terms of learning goal is to actually run the example code that we have, which sets up the A/B testing infrastructure, because that's the part which is adjacent to the models themselves. So A/B testing infrastructure is just about every time a user comes, they either go to part A or to model A or model B. Okay, that's what we want to kind of at least do it in a small scale toy example situation. Okay, so that's the goal for the next hour or so. And if we have time, we'll see if we have time. We'll also look at ML model pipelines. There, the goal is to, I think instead of going through those goals, let me finish this and then we can talk about those goals when we get there. Okay. So, but before that, I think it's a good time to take a short break for 10 minutes, and let's resume at 7:28. Okay. So let's resume at 7:28. And if you have questions, you can use the chat. But let's take a break and come back. Yeah, so let's resume. Share my screen. Yeah, so as I said earlier, right before the break, we're going to switch topics and look at model retraining, versioning, and testing. In particular, we'll start with testing first today, and hopefully we'll cover testing today and then talk about scheduling and versioning next time. Okay, so the testing specific slide, actually a couple of slides, actually very brief slides, slide 16 and 17. So Okay, so what we look at is basically A/B testing. Okay, so here's a illustrative diagram, and we'll actually spend a couple of minutes. I want to tell the gist first from the slides, and then we'll look at the details in the lecture notes. Okay, so just as basically when users come to your website or service, or kind of get exposed to your ML models somehow, maybe it's personalizing prices, or how they, what is displayed on the app, or recommendations and so on. Then how do you validate which model performs the best? Okay, so for example, in this illustration, just for the sake of illustration, there is two versions of models or websites, and one website is basically just has a blue button, and the other website has a green button, okay, with an extra like an arrow in addition to learn more here in this learn more button. And then users come, and A/B testing is all about randomly assigning users such that they're exposed to either the first version of the website or the second version of the website, or in general terms, first version of the model or the second version of the model. And then you kind of expose a collection of users like this. Maybe you pre-decide on the number, let's say 1,000 users. Hopefully about 500 are exposed to the first version and 500 are exposed to the second version. And then you look at some aggregate statistic of what happened, what's the metric for the when users visit the first website or the first version, and what's the metric when users visit the second version. And then you look at some summarizing metric like a P statistic or something like that, and then conduct a hypothesis, do a test to show whether the P value is low enough to reject the null that maybe the two versions are the same, for example. Okay, so the list of tools is actually, there are many vendors out there. I mean, so there's a very big enterprise company which focuses on enterprise customers called Optimizely. There's also other smaller companies like StatSig. What we're going to try out today is an open source package called Planout, which lets you deal with the setting of the infrastructure to be able to expose users to one version of the model versus the other. Okay, so that's and that is actually relatively straightforward, but we'll see how to do that. And the second thing is, as I said, once you set up the infrastructure and collect data, then you need to run a hypothesis test itself, and that you can do again. Depending on the complexity of the situation, you may need more elaborate hypothesis tests, but we can just do a two-sample unpaired t-test. Okay, so that's the gist. So on the surface, in theory, it seems pretty straightforward, but let's see what the nuances are. Okay, so the outline is, we'll just discuss A/B testing and in general statistical tests that back it, and then we'll look at our example. Sorry, can you see this? Our example, which is about comparing model 1 versus model 2. Okay. Just give me 1 second. Okay. Okay, so let's start with the basics of A/B testing. And if you have questions about this part, as usual, please use the chat, or you can always unmute yourself. So A/B testing is also called randomized test, randomized control trial, or split test. Okay, so it's actually its roots is in science, of course. So it was used, or it was predominantly used for several decades. It is still being used in vaccine trials and trials for new medication, right? So they're typically referred to as randomized control trials, but in the web parlance, they're generally called A/B tests or ABN tests. Okay, so what are these and what is their role in machine learning, right? So their role is their data-driven way to communicate to business stakeholders that your ML solution, whether it's a personalization solution, pricing solution, maybe whatever it is, it produces a tangible lift in the real world. Okay, so a lift could be in terms of doing well in terms of retention of users or customer churn or marketing or whatever the metric is. Okay, sales, conversion, so on. And the advantage and disadvantage is that A/B test is very simple to set up, and that's why we are simple to understand for business stakeholders actually. But at the same time, it is also easy to misunderstand. Okay, it's a double-edged sword, but nonetheless, it's one of the simplest instances of a thing that typically companies which or teams which keep improving on models and keep building better and better models, they generally have this tool as a way to quantify how well, by exposing your model to the real world to see how well your model is doing, rather than just rely on offline metrics and not track what's happening online. Online just means when it's really exposed to the real users. Okay, so it's basically, especially with ML model deployments, there are cases when it's a greenfield project and you're building the first ML solution. Okay, so A/B testing may not be, I mean, even in that case, A/B testing is useful when you compare it with some hand curated or some rule-based system that was there before. But it actually definitely makes sense when you join a team and the team has already released several versions of a, let's say, machine learning model, let's say a recommendation system model, and you come up with and you work on a new model. And so there's an existing model that's already recommending and it's doing well in terms of some sales, conversion, engagement, or whatever. And then your new model may have better offline scores like precision recall or whatever you want to use for recommendation systems. But how does it do online? Okay, so that's always a question. So it ideally should not do worse. It should not reduce engagement, or it should not reduce sales and so on, right? So that's how it's typically used in the real world to demonstrate value and value to a heterogeneous set of stakeholders, not just the technical folks, but also product managers and business folks potentially, right? There are other tools that some of you might have seen in, let's say, 576 or elsewhere. There are tools like multi-on bandits and others, which try to be sample efficient while doing something like A/B testing. Okay, sample efficient just means how many users do I need to do this randomized control trial or A/B test on to figure out whether the new model is better than the old model. Okay, maybe it's 1,000 users in A/B test. So that means that for 500 of those users, let's say you're doing model 1 versus model 2, that means for 500 users, the experience was subpar because 500 users were shown one of the alternatives, right? So in more advanced solutions like multi-on bandits, what you can do is be adaptive so that if you know one of the models is winning, as in like is better, you kind of expose that to more users so that over the same 1,000 users, lesser people have subpar experience. Okay. So as I mentioned in the slide deck, there are several vendors and all the big tech companies have something to do with A/B testing, and there are also a lot of small companies. There's also a lot of open source implementation. So these are more about setting up the infrastructure. Remember, for the past 3 lectures or before that, we've been focusing on setting up our ML prediction service in isolation. Okay. So just imagine there were 2 such services. One is the one ML prediction service for existing ML model, another ML service for a new model. Now you can imagine how an A/B testing infra would be needed so that incoming requests can be routed to either one service or the other, right? So that's exactly what these implementations, these auxiliary pieces of software do. They help you, do this splitting of users at random to one, so that they can be exposed to one version or the other of your model. Okay. So why do A/B testing and not just rely on offline data, right? So that's an important question to ask. Okay, just give me 1 second. So I think my AWS machine is stalling because of some reason. But okay, maybe we can address it when we get there. So, okay, so why do even A/B testing and why not rely on offline metrics? Okay, so one of the key reasons is because of bandit feedback, as in if you think of offline metrics, they're working, it's like precision recall or, or things like accuracy and so on. They're computed on, let's say, held out, or validation data set, what do you want to call it? That data set was generated based on the previous recommendation model. Okay, so in the sense that the data set that you already have on hand is actually biased. It's biased by the previous policy or the previous recommendation model that you use. Okay, and so what's the issue with this bias? So what's the issue with this is that the previous recommendation model tried to show item A versus item B. So let's say it showed item A to recommend to users. Okay, and maybe the users responded by purchasing a product or not purchasing a product. Now the question, the problem with this, the data is biased precisely because you don't know what would have happened if the model showed item B to the same user. Okay, so that's what we mean by bandit feedback, or a feedback or a data which is biased, which is that the counterfactual questions are not answered. Like what would have happened if the model or recommendation model or pricing model did something else than what it actually did. Okay, so given that feedback kind of messes up your offline data, that messes up your offline metrics. Okay, so offline metrics that you're computing are biased, maybe either underestimating, or overestimating the performance of your new model. And so certainly using offline data, as much as possible makes sense. But after that, you do want to do an A/B test so that you can have unbiased exposure to new users and kind of unbiased exposure to users and see whether your model actually performs better or not. Okay. Is this point clear? Why we need to do A/B tests and not just rely on pre-collected data? Okay, so the mechanics of the test. So let's talk about stage 2, because so as I said, A/B testing, the whole process involves 2 steps. One is the infrastructure to actually collect the data under the 2 versions, which is what we will try out using code. But that's one part, and part 2 is actually to do a hypothesis test once you already have the data. Okay, so that is actually pretty familiar and hopefully somewhat straightforward to some of you, which is that we kind of rely on statistical tests. Okay, so let's assume that we are only comparing, for simplicity, only comparing what we call as control versus a single treatment. So in A/B test, A corresponds to one version, one model, and B corresponds to one version of one model, right? So typically, let's say A is called control and B is called treatment. You could have A, B, C, where one control and 2 treatments, or you could have any such combination. Okay, so let's say we're only doing a control versus treatment. Of course, if you have more than one treatment, then the test will slightly change. But let's look at some of the terminology that's needed to kind of define and run this test. Okay, and some information from here is actually also useful to define how long your A/B test has to run. Okay, so we look at some tests. Here are some example names of tests that we will one could use. One is the first one is 2-sample t-test. The second is a chi-square test, and the third one is a Poisson's mean test. Okay, and why do these test choices change? They change based on what metric you're tracking. Okay, so if you're tracking the average time, let's say a Netflix, and you're tracking average time and a person spends on your spends on your app, so that is some real number, right, between 0 to infinity. And so that so the corresponding test statistic would somehow how much time they spend in the next week or so. So then that's some real number. And so that requires that will result in a certain test statistic. Similarly, if you're looking at how many ads were shown and out of which how many ads were clicked, that's like some sort of a proportion, right? Some click rates. And so because its click rates are not absolute numbers, these types of absolute times, and so the underlying test statistic will be different. Okay, so if the test statistic is different, the underlying test will also be slightly different. Okay, so let's actually talk about, although the tests could slightly vary, and we'll see a couple of examples in a second, the considerations are similar across all these tests. So if you have an A/B test you want to set up, then you want to, for part one, what is necessary is that you need to specify how long do you want to run the test. By how long we want to run test, it just means that how many users need to be exposed to control and how many users need to be exposed to treatment. Okay, so is it 500 users versus 500 users, or 1,000 users versus 1,000 users? Okay, and for that you need to have a priori, like you need to have a sense of what is the effect that you want to detect. Okay, what is the minimum effect that you want to detect? So what is a minimum effect? It is the relative improvement, let's say. So it's a relative improvement over the control. So for example, if you're tracking a metric like average time spent on my app, okay, so it's, let's say it's 20 minutes, okay, and the current ML model is producing recommendations or whatever, so that the user is spending 20 minutes on the app. Okay, now the question is, what do you think your new model would your new model would result in, like in this metric? So let's say instead of 20 minutes, you're hoping that maybe it's going to make users spend on average 25 minutes. Okay, so then the relative effect is 25 minus 20 divided by 20. Okay, so it's like 5 by 20 or 25%, right? So your minimum detectable effect is about 25%. Okay, so given that, and also some other also a couple of other choices, like how much of type 1 error can you tolerate? How much of type 1 and type 2 errors can you tolerate? Okay, so what is the minimum detectable effect size, and how much type 1 and type 2 error you want to tolerate? Depending on that, you can estimate what is the number of users, which is called sample size per variation. What is the number of users that you need to expose your model 1 and model 2 to? Okay, so so this is the sample size calculation, and there are many tools to do this. So let's actually look at one tool right now. So here's an example, right? So yeah, here I guess here is 20%, but you can change it to 25. So let's say the baseline conversion rate. So here we're talking about conversion rate. Let's stick to something like actually, let's actually go back there. So yeah, let's stick to conversion rate. So let's say the minimum detectable effect size is 5%, just like I mentioned, and baseline conversion rate is actually 20%. It's the same as before. Sorry for that. It's an absolute 5% improvement over baseline conversion rate. So we are talking about conversion rates instead of 20 minutes versus 25 minutes. So let's just change to 20% conversion versus 25% conversion. So conversion rates are just, if your model recommends something, what is the probability with which the person is going to buy? Okay. So maybe one model has 20% conversion rate, the other model you're thinking would have 25% conversion rate. So that's before doing the A/B test. So based on that, you are saying, based on that, this website, is just computing how many samples do you need per variation. Okay, how many samples do you need for variation if you control what is called type 1 error and type 2 error. Okay, or power, which is the opposite of type 2 error. But so there are 3 choices you need to make. What is the minimum detectable effect size? What is the level of type 1 error you're willing to tolerate, and how much power do you need? If the effect exists, what's the probability with which you want to detect it? Okay, so given that, you can compute what's the size needed. So you can imagine there are some nice trends, right? So for example, if your model is already so good, the baseline model or the control model is already so good so good that the minimum detectable effect size is actually only 1%, let's say, then you can see that the sample size went from 1,000 to 25,000. Okay, so it's a 25x increase in sample size if you are already in the 10th model and then you join the company and now you have to create the 11th model, and you know that you've already kind of exhausted many of the tricks, and so the incremental improvement will be small, but you know that there will be improvement, but it's small. Okay, but if you want to detect such a small effect, you need to run a test for a much longer time. Okay, any questions about this part? Okay, so if not, let me actually come back, but let me restart my machine so that I can demonstrate. So, I mean, when I said restart my machine, I just mean the remote machine. So let's see, is it, okay. Okay, I just rebooted the remote machine. It was just some minor error. Okay, so let's actually come back. Okay, so we were talking about sample size for variation. I hope it was clear that you need more samples if you want to have a small effect size. And then in this section of the node, we are just talking about a couple of different metrics. Depending on the metrics, the test will be different. For example, if you have kind of a real number, like some average value difference between two groups, then it's basically an essentially two sample t-test. And so in the same link, we can see for the two sample t-test, basically it's a question of like, what does sample one mean, sample two mean, and what is the difference of the means. And if you if your null hypothesis that the samples are, the two means are the same, which is first one, sample one mean is 58 and sample two means 33. Okay, if your hypothesis is that, but your confidence level you want is 95%, then the verdict is sample one mean is greater. So which is like 58 is greater in the sense that sample one has higher numbers. So what if I add, let's say, a 0? Okay, so if I add a 0, now sample one's mean has reduced to 51. And so now you can see that the hypothesis test is basically saying it's not able to reject the null hypothesis that the two samples are different. Okay, so it's just play around with this to get a feel for how hypothesis tests work. But let's come back to our setting. So chi-square test is related to rates of events, and then Poisson is about number of events in a given interval. So for example, hey, given my ML model in the next 1 week, how many times does this person do X, Y, or Z, right? So if you count those events, those are like, you can assume that they're Poisson distributed, and then you can do a Poisson means comparison. Okay. There's no need to remember all these tests. I mean, so it just there are references that you can look up to, which will tell you which test is appropriate for which situation. But before we try out our model testing example, last couple of comments about testing itself is that one of the biggest, there were pros and cons. Pros is that A/B testing is very straightforward, as you saw from my kind of comments earlier. But the con is that it's very easy to make wrong conclusions. Okay, one of the misunderstanding is exactly what p-value itself means. Okay, because people report p-values, it's some some numbers, and the question is like, how do you interpret that, right? So the interpretation is actually as follows, right? P-value is assigning the probability that the observed event under the distribution governed by the null hypothesis. Okay, it's just a probability of I observed something, some event, let's say mean being or the mean difference being some units. What is the probability of this observation under the null hypothesis? Okay, that's what a p-value is. And so sometimes it's hard to convey exactly that this is the interpretation and not something else. And there are also other gotchas, which is, for example, most tests that you see in textbooks and so on, they are for a fixed horizon. Okay, fixed horizon just means you need to decide n a priori. Like here we did, we said, hey, n, you need to show 1,000 observations. Sorry, you need to have 1,000 users per variation. Maybe which means that 2,000 users. Let's say you only are doing A/B tests. You have 2,000 users to expose to, and you randomly assign users to A and B. You cannot stop. You cannot stop your test at, let's say, after 500 users. After 500 users have been exposed to one of these A and B options, and conclude anything. Okay, so you cannot stop unless you want to have a valid hypothesis at the end of the thing. Okay, so in particular, stopping only when you get a significant outcome inflates the rate of false positives. Okay, and this error is called peaking. Okay, so peaking in p-values is a big issue. Not just in A/B testing in the tech world, but also in sciences, especially social sciences. There's a lot of discussion on this. As I mentioned earlier, there are adaptive testing techniques that allow you to not commit to one sample size in advance, and they require more advanced, I guess, background and skill. Okay, as well as usage of the tools that I showed earlier. So let's actually. So any questions about this part before we jump into practically trying out a model? So is the context clear? Like why A/B testing and how to do it? I mean, at least the stage 2, there needs to be a hypothesis test, and it has its own. And stage 2 also informs a stage 1 in terms of how long to run the test and so on. Okay, so then we can just jump into let's see. Okay, what happened is my SSH connection failed because I restarted the machine. Okay. Okay, so what I'm showing you here, I just had to restart the machine, so Jupyter, of course, terminated. So what I'm showing you here is the A/B testing example directory. What I'm going to do is do a couple of changes so that we don't have to run the whole thing. Let me actually see if I have. So just be careful running train. So train actually doesn't run well, at least on the AWS machine that I chose. That's because it's running a heavyweight deep learning model, not heavyweight deep. It's not too heavy, but it's at the same time, it's not too small. It's also loading a large data set. So instead of that, let me see if I have a trained model beforehand so that I can just use that. Okay, so let's see. So let me discuss this and see what dependencies there are. So okay, so there is a dependency on models and movie lens data. So how do we fix that? Okay, so okay, let's actually okay, for the purposes of the A/B testing, I think what I'll do is not worry about models. So the specific recommendation model, and I'll show you with the model bits commented out. Okay, so let's understand. So in this directory, in the A/B test example directory, there are several files. Okay, so we just need to focus on 2 files: Flask model testing and 2 sample tests. Okay, so 2 sample tests I'll open in a second, but let's look at Flask model testing. Okay, so you see a lot of imports going on. So I will ignore things which are not related to us. So I mean, not very relevant to the setting up of the A/B testing infrastructure. So what we need is a package called UUID. It's just for creating randomized randomized identity files. Sorry, not identity files, but randomized strings for each user visiting our service. Okay, and then we need Flask with some extra imports like session, so that the server can remember who was the person who came to this website the last time. So this is, again, I think somebody asked earlier, how do you continue with the same continue with the same user next time, right? So session lets you put what is called a cookie into the browser. So it's on the client side. On the client side, you kind of keep a string basically, or some alphanumeric string, so that you remember that it's the same user who visited your website like yesterday or earlier. Okay, so you need some state, and this time the state is on the client side. Okay, request, redirect, and rendering. These are just helper functions. So the extra package that we're going to use is called planout. Okay, so planout is the package that's letting us split the user so that they can be exposed to model version A or model version B. Okay, so we can actually write this out yourself, but soon you'll see that there's going to be some considerations that are needed. So planout is a nice package from almost a decade ago by some researcher at Facebook. So it gives you a sense of how this is done. Okay, so Optimizely and some other vendors do this for you in much more complex situations. But so planout is an important import. Okay, so these imports are what's related to the A/B testing infra. Okay, so what you do is so you extend the class simple experiment. So what are you trying to do? It's just setting up, hey, dump the if there's any model metrics that you're tracking, you want to write it somewhere. So for simplicity, we are just writing it into a text file called model_A/B test. And here's the this class, an object of this class is it's going to have a method called assign, which will just say it's going to flip a coin. Basically, it's going to flip a coin based on the user ID. Okay, so based on the user ID, it's going to flip a coin with some probability, 50% probability. and then that will set a flag called use model 1 or use model 2. Here it just says use PyTorch. If use PyTorch, use model 1. If that flag is true, then use a model type is PyTorch 1. If not, PyTorch 2. Okay. So actually, okay, let me just change it to model 1. Let me call it treatment maybe. Control model and treatment model. Okay. So this is just use control. Okay. So use control, and a model type is, if it's control, model type is control, as treatment. Actually, you don't even have to do explicitly like this. You can also just use control later. And then there's a lot of information unrelated to A/B testing. So let me just comment those things out. Yeah. So I'm loading a model, but to show this, I don't need to have the model. So let me I don't think this is needed. So I'm just gonna make this something maybe. So we'll see. I mean, some number 11 doesn't matter. Actually, do we even need this? We don't need this. Okay, so now this is the part. I mean, so the model part was not that interesting. You can always load any 2 models if you want in this example. So we create a Flask app. There's a in Flask app, you can actually set it to be debug mode or non-debug mode, and also a secret key. This is actually useful for preventing some. It's for some security reasons. We'll not get into the detail here. Let's really focus on routing and the splitting of users. So okay, so here's the thing, right? So when users hit the root, default root, then you call the main function. So the first time a user comes, if they don't have an ID, so there's no authentication stuff going on in this example, by the way. If the user doesn't have, basically, if it's a new user, okay, so check the session cookie of this user. So if the user ID is not present in the session cookie when the person visits this browser, then I'm going to create a new user ID. Okay, so this, I think, some number. So just create a new user ID, and then what you do is create an object of this model experiment. Okay, so that object is what's gonna set. Once you create that object, it'll and then when you call the get a model type, it will create the type of model that needs to be shown to this user. Okay, so if you go back here, so once you create this object, this assignment. So when you call the get method, the get method eventually is in the simple experiment definition, and it's going to essentially assign one of the model types, either control or treatment, to you. Okay, and so that's the one extra step that you're doing in the Flask model, Flask main function. So you're just asking here, which model type should we assign to this user? Okay, and response right now is false, and then model type, response, and session ID, that's all fine, is printing. So if model type is, let's say, control, it's fine. We don't need to care about all this. Let's ignore. Okay, not them, but we already have the value somewhere. Okay, let's call it user ratings themselves. Okay, so what we're doing is fetching the predictions of the models. I mean, here it's just putting some default values, and then, okay, we don't even have to. If it's a list of something, then let's actually create the list. Okay, so it doesn't matter. So let's put some numbers there. So it's just responding with some list of ratings. Okay. So, and then what we're returning to this user is, hey, you are this user. Here's my response, and here's the model type is relevant to you. Okay. So and that ends that, and this all HTML stuff is just to show it in a nice manner. Okay. So this try is if if the user is of type control or treatment. Else you show, if else you kind of show something else. So let's actually run this and then yeah, let's run this and see what happens. Okay, so so if, there could be some small example, typos. Let's see. Oh, wow. How come there's no pandas? Okay, I never installed pandas. I think I also need to do pip install planout, I guess, but we'll do that. I mean, we don't need pandas, but I don't know. Okay, so it's running at port 5000. What is the best way to, I think what I'll do is expose it to the internet, I guess, and then, so that requires, I mean, I think in my security groups, 5000 is not exposed to the world. Let me just check that. Okay. And I don't remember the IP address. So let me just check the IP address. Okay, so what is happening here is, I mean, I just randomly generated some user ID, and recommendation is three is just because I just arbitrarily chose here. Let's come back to what's going on in the script, right? So let me minimize all this. So let me come back actually and delete all the irrelevant stuff so that it's more clear what's going on. Torch pandas is not needed. Time perhaps. Let's actually keep all this. So what's going on? Some imports related to setting up the Flask app, as well as the way to split users into users who will get exposed to version 1 or version 2, or basically control or treatment. Okay, so we're gonna write a. So this planout is what's helping us, create some small things. One is every time a user visits, we can actually log what the user behavior is. Okay, so in model underscore A/B test, like what did user do? Did they we showed something? Did the user click on something or not? Okay, for example, like that. And the second function which you need to define is given a user, what should the which version should we expose them to? And here I'm just flipping a coin. Bernoulli trial is again a object, that's something that's available in this. And so you flip a coin and say, whether they should be exposed to control or treatment. Okay. And you don't need start time and all that. So let's drop all this. And then you set up a Flask app. Actually, this is, this stuff is optional for now. and you have the get method. Okay, so it's just saying if there's no user, at least create a user. I'm just creating a random user ID for them, but you can always do something more intelligent. And then for the person who logged in, so person who opened asked the first time information from the server, we are just creating a so first of all, we are remembering who this user is by creating. So remember, this session object is something that we got from Flask. Okay, so Flask is a web framework which lets you create a cookie on the client's device, in this case, in the browser. So if it's a new user, I'll just make them. I'll just give them a user ID. Okay, so I'll just give them a user ID so that next time the same person, let's say it's 575, right? My user ID is 575. If I refresh this browser, okay, if I refresh this, I should, my user ID doesn't change. If you guys visit this website, okay, let me just put the link in the chat. Right, if you visit this website, you will get a different user ID. But if you close your browser, open your browser, as long as you're not clearing your cookies, you should see the same ID. Okay. And if you want to, reload without resetting your user ID, this is how you do it. Like, and then if you want to reset your user ID, there's another link which will clear that user ID. So now it's 154. Now every time I refresh it, it's 154. Okay, I hope that clears an earlier question that was there in the class. So now let's come back to the Flask app. So what's going on? So if the user is not there, I'm just creating some ID, but I'm remembering it. Okay, so I'm remembering it. That's why it's a session object has a field called user ID that I'm adding. I'm actually creating the field and I'm adding some user ID. Okay, so for this user, I'm just saying get their model type. Okay, if it's a new user, I'm gonna flip a coin and assign them a model type. If it's an old user, I'm not gonna. So this get model type will already have a value. So I'm just gonna expose them to the same model. So this is the complication that for you to write it yourself may need an extra logic. But here, if the same user visiting the same app, 1 hour from now, they should be in the same version of the experiment. Okay, that's typically expected. And so, so you get the model ID. Okay, and then based on whether the model is control or treatment, I'm just returning 2 or 3. So here you can see that for user ID 154, I'm returning 3. But if I reset the user, okay, it's not changing. Oh yeah, so for user 625, I'm returning 2. Okay, so you can imagine instead of 3 and 2, you can imagine 2 different models, 2 different recommendations being submitted, right? And the rest of the logic is just, it's not really logic, it's just what you want to return. So I know what I want to return, that's being printed. So where is this being printed? This is actually in debugging mode. So I'm just printing it right here. So I'm just saying, what should be my response, and what is the user ID, what is my whether this user is in treatment or control, and what is my response. Okay, this is just for debugging. It looks like a lot of different IPs have accessed, or maybe not. Some folks of you seem to have tried, but that's what's happening with this app. Okay, so and the rest of it is just a nice way to kind of show the same thing in the browser. So just, this is not even that nice, but just to show this, that's the that's the HTML code. So is that clear? Like how we are achieving exposing them to model one, control versus treatment? Because this is the only new thing which we've added. So we are familiar with how to run a Flask app, just to get a request, call model.predict and respond, right? What it's doing in addition to it is create an object so that we remember. I mean, first of all, we remember what this user is from next time this person visits, because we are maintaining a cookie with some information in the cloud browser. And every time they visit, we kind of, we want to remember what model type that we want to show them, either the control model or the treatment model. And then once they hit the URL, once you know which model to show, you can always call that model, right? So here, I'm not calling the model. I'm just showing a list. And so it's just picking up number 2 or 3. And that's just specific to this logic, but that's what's going on. Okay. Any questions here?
Professor, in terms of deployment, this HTML part, do we need to know all of this? Or
No, this is just for beautification purposes. If you wanted to use with web pages, then you can always do the simplest web page. Okay, so this HTML, you don't need head, for example. you don't need, you can just do a text, right? Instead of this crazy HTML stuff, you can just do text. Okay. How do you give information that you want to show in a HTML page? Okay. So for example, instead of this HTML stuff, so far we've been only using something like return JSONify, some dictionary, right? Some, return, object, right? Something like this is what we were doing before. Sorry, that's not the right. But so you can always return a JSON object. You don't have to worry about HTML if you want to do it as a prototype. Okay, this is just to add a little bit of functionality so that I can just click on something and change my user ID. So I can refresh, my user ID doesn't change. If I refresh with the second link, my user ID changes. That was just a minor thing. And so submit query, like what is my rating? My rating is 10, and go back and stuff like that. So this is just for this functionality that I added HTML. So don't worry about from lines 59 onwards. I would just suggest have a look at it, but it's not critical for this thing. Okay. And if you look at model.log, the planout package also helps you see who came in at what time, what's the name of the experiment, what time they came, what is their user ID, right? Whether the control was true or treatment was true, what was the event, is the exposure event or a conversion event, and things like that. Okay, so for example, I don't think anybody else rated it, but at some point I did a rating, so it should show, yeah. So I did a rating, so it shows there was extra data that was available, and it's a rating. So play around with the script, okay, in the A/B testing example to get a feel for like something is being logged and users are being remembered so that they can be bucketed into either control or treatment. That's the only extra stuff. Everything else should be exactly the way you've been exposed. Once you get a request, how you kind of make a prediction is the same as before. Okay, so once you have that, okay, let's say you set up. So this was the part where you need to run this experiment, and you'll have to stop it right after some number of samples per user. You need to stop it so that you can now do a post-hoc analysis. So that is not being shown in this minimal example because it's always bucketing users into control or treatment. What you could do is change this proportion. Okay, so after some time, if you prefer one versus the other, you can change this probability to 1 or 0 so that after the experiment, people always go to always see one model if you want. Or if you want to change the whole script and rerun it, you can do that as well. Okay, pick one of the models, which is the winner. But how do you pick the model? It's pretty straightforward. So here is an example. This is also there in the same folder called A/B testing, right? So here's a very simple example. So I read the model. So I read the log file, some extra processing here. And I want to get people who are actually, if they have extra data. Okay, so if they did do the rating. So if I just look at the log file, it'll be something like this, which I just showed you, like who's the user, which model did they see, and what did they do, right? So, but if they actually give ratings, then you can kind of do some cleaning up, and you'll see something like, hey, rating value was 3 for control, for treatment rating value was 7, for treatment rating value was 0, and so on. Okay, so eventually you want something like this, whether this person is control or treatment and what rating they gave. For example, if rating is the conversion, otherwise you can just see, hey, whether a sale happened or not, okay, instead of rating. And then once you have that, you just create a simple 2 data frames with, just look at the collection of ratings for treatment, or collection of metrics for treatment, collection of metrics that you tracked, events that you tracked for control. Okay, so there'll be a bunch of numbers. Once you have those numbers, for example, in SciPy, using SciPy, doing a t-test is very, very straightforward. You can do SciPy stats t-test independent of these 2 NumPy arrays, and you can get some p-value. Okay, so given the p-value, you'll not be able to reject the null that the 2, in this case, in this example, you'll not be able to reject the null that the 2 samples are different. Okay, so but you can imagine if you did something very different and run a t-test, then the p-value is extremely low, and you may be able to reject the null. So for this, I would suggest look at sample size calculator to get a sense of like what's going on, like what is the number such that the test statistic is some value, and how do you say one sample is better than the other, and so on. Okay, so I don't want to open, I don't want to scroll through the whole model notebook, because I think it talks about recommendation models. I think I sidestepped it today because of some training reasons. So, okay, so just as a caution, don't run the training script in your AWS machine, because I think the AWS machine, at least the one I picked up in the first lecture, is underpowered. It only has 2 cores, and it's a deep learning model that is being trained in the script, so it requires a little bit more computation. Okay, but you can always choose, instead of deep learning model, you can swap out and use some other model, right? Any other question that you guys saw today or you want to discuss? If not, let me summarize where we were, right? So let's zoom out again. What we went over the past half an hour or so was a specific example package called planout, and some extra extensions to Flask, so that we were able to do bucketing of the user, like put the user in either control or treatment, and remember it the next time user comes. Okay, remembering part was using a session object, which is basically a cookie on the client browser, and every time the user comes, we look at the we look at that session information to say, hey, this person is user X and this person is in control or treatment. Okay, and if we are in control or treatment, you show a different model. Okay, that's what we're doing. So to summarize, the goals of this section were to kind of get a feel for A/B testing. In the real world, it exactly works like this, except there'll be more robustness to the code and maybe external tools involved. But know when A/B testing is useful. It's actually very useful when your real world data set can be influenced by your model. Okay, in that case, offline evaluation is not enough, and which is the case in many realistic situations. And so you would need to do A/B testing to convince stakeholders as well as yourself that your new model, for example, is better than the old model. Okay. There's hypothesis tests involved behind this, in stage 2 of A/B testing. They depend on what metric you're tracking. By the same time, you don't have to remember all of them, but they do help you determine sample size a priori. Okay, and note that there's a lot of pitfalls with A/B testing, like peaking, stopping the test adaptively when you feel that you got a significant result, always computing significance, or doing multiple hypothesis tests after collecting the data once, and things like that. So there are a lot of pitfalls. At the same time, it's simple enough that it's quite popular in the industry. And the last point is we tried out planout with Flask to see how it worked, and hopefully it was a little bit clear. If not, reach out to me offline. Next time we'll look at scheduling and versioning of models. Any questions? Okay, if there are no questions, then let's pause for today. Stay back if you have comments, and if you have comments about your projects or about what we saw just now.